Hi there! Welcome back to another chemistry lesson. The scientific approach to knowledge is what makes science science. So let's talk about it. So here is a diagram, a flow chart of how science works. And it always starts with observations, which lead to hypotheses about what's going on, which lead to experiments, more hypotheses, laws, theories, and all of that. In order for science to be trustworthy, we have to have a systematic way to approach gaining new knowledge. So the scientific method is our way of doing this. All good science starts with an observation. This observation is our data, and that data can be either quantitative, which is numbers, or descriptive, or qualitative, which is not numbers, opinions, things like that. That would be descriptive data. Now, these data often lead to the formulation of a hypothesis, which is a tentative explanation or interpretation of the observation that you made. And the important thing about a hypothesis is that it has to be falsifiable. If the only option for the hypothesis that we've made is the answer, yes, this is true, how can we trust that it really is true if there are no other options? So an example of this would be, is there a God? Right? And this is not a statement on my religion or your religion. It's just a fact that there is not a scientific experiment that we can do and say, if this happens, there is a God. If this happens, there is not a God. Because we can't say, no, God didn't do this definitively, then that would not be a good scientific hypothesis. You are welcome to think whatever you want, but that doesn't make it scientific. And that's the key here, is in order for it to be a good scientific hypothesis, it has to be falsifiable. Then, once we have our tentative explanation, our hypothesis, then we do an experiment. And the experiment does not prove or disprove anything. It just supports or does not support the hypothesis. And that's the important thing that I think gets misunderstood about science, is that we think that if an experiment has whatever sort of result, that proves that this is true. One of the main things about science is that it is always changing. Our knowledge is always increasing and adjusting based on new information that's coming in. So, a hypothesis is not proven or disproven. It's just supported by what we found in our experiment, or it's not. And then maybe later we find some conflicting information from a different experiment. So, it's just supporting or not supporting the hypothesis. And once we have many experiments that support the same hypothesis or group of hypotheses, we can create a theory, which is a model for explaining why nature behaves the way that it does. It is a general explanation for the characteristics and behavior of nature. It can be validated and adjusted based on future experimentation and can be used to predict future observations. So again, we have this cyclical method. We've got observations that lead to a hypothesis. Well, then we test that hypothesis with an experiment, and we can confirm or support our hypothesis, which can lead us to other hypotheses down the road. When we get a whole bunch of these, we can get a theory, which can be adjusted based on other experiments. And then we eventually can also end up with a scientific law, which is a mathematical type of approach to this. So, as you can see, the scientific method is just kind of cyclical and allows for adjustments on our previously known information.